Okay, let's see how to work through one of these algebraic simplification problems that are multi-step, I'll say. They're a little more complicated. So this idea of difference quotient is something that you will see again in a calculus course. And it actually has to do with the rise over run. This right here really is a measurement of slope. It's a rise over run slope. But it doesn't really matter where that comes from to do the problem. If we know that f of x is equal to this, then we should be able to build any expression based on x's and h's and f of x's. And then once we have an algebraic expression, we should be able to simplify it. So, so the main thing is take a deep breath and just do it one step at a time. So in this expression here that I'm supposed to simplify, first I have to build it correctly, which means I need to know what f of x plus h is. That's this piece. So I'm just going to do that separately, so make sure I get that right. F of x plus h means take your f of x function, and where the x is, replace the x with x plus h. And now, when I do that, I want to make sure that I use parentheses, because after all, when this says negative 2 times x, it means negative 2 times all of whatever x is. And so when I replace this letter x with something more complicated, I want to make sure that this negative 2 is multiplied by that whole thing. So that's why my negative 2 here is by the entire thing that I'm placing in place of x. So this is what f of x plus h is, and it's certainly worthwhile to simplify it before going on to something else. So this is just the distributive property. This negative 2 gets multiplied through, and then I have this guy here. There is another problem in this set, which probably somebody else is going to ask me about, where this is quadratic, and so it's much worse because I'll have to plug x plus h in for x and do FOIL and all kinds of stuff. But eventually, I can simplify f of x plus h completely. And so that's really the key, is to do that separately. So now back to the problem. I'm supposed to take f of x plus h, which is this, and subtract f of x. Now f of x is just this, right? F of x equals this. So that just means take your f of x formula and you're not replacing x with anything. X is just x. So this is f of x. So I'm going to write that down here too, just to remind myself. F of x itself is negative 2x plus 4. So the f of x part of the difference quotient is just the formula we're given, and the f of x plus h is the formula we're given, but with x plus h in terms of x. So that's this guy. All right, so now we have a simplified form for f of x plus h. We have a simplified form for f of x, and so now we're ready to build this entire expression. So f of x plus h minus f of x over h is equal to, and I'm going to use parentheses here to make sure I don't screw this up, f of x plus h is this guy. So I'm just going to write that guy down, minus 2x minus 2h plus 4. And notice that I'm putting in parentheses just to make sure I don't mess anything up. This f of x plus h is all of this, and so I've just changed this into this. Now I'm going to subtract f of x, and I'm going to put that in parentheses, again to make sure I don't mess that up. So again, f of x is just this, so subtracting f of x is subtracting this entire thing. So I subtract the entire thing. So when I'm replacing something simple with something more complicated, I'm going to put the more complicated thing in parentheses every time. F of x, that's simple. This guy's more complicated, so I'm going to use parentheses to make sure I do it right. And that's over h. Okay, so now I have to be careful about my subtraction. I see I have a plus 4 minus plus 4, so that's a wash. So that is going to be 0. Plus 4 minus 4 is going to be 0. I have a minus 2x minus a minus 2x, so that's minus 2x plus 2x. So that's nice, that simplifies. And you start to see why in calculus the difference quotient is significant, because there is a lot of simplification that happens here. And since it actually represents something to do with slope, and it actually is algebraically nice once you simplify it, those are two parts of the recipe for differential calculus. Anyway, so we're almost done. The only thing left in the numerator here is this minus 2h part. So I have minus 2h, so that's 2 times h over h, but that's multiplication. So negative 2 times h over h is like negative 2 times h over 1 times h, and we learned that as long as there's an h that's multiplied in the numerator and in the denominator, that it can be canceled out. So that h in the top and the h in the bottom cancel out, and I end up with negative 2. And so it turns out that the answer there, this difference quotient, simplifies all the way down to -2. In calculus, you'll learn that this difference quotient is a measurement of slope. It makes sense because this, as a line, the graph of this guy, has a slope of -2. And so if you believe that the difference quotient measures slope, it makes sense that the answer ought to be the slope of the line, which is -2. So that's exactly what happens. The nice thing that you'll learn in calculus is that even when the f of x formula here is not a straight line, we can still make sense of the difference quotient, and so we can still measure slope of things that are not straight. And that is the getting way ahead of ourselves in the calculus world. But for these problems, it's just a matter, this is really an algebra problem. It's really a problem in making sure that we can plug complicated things in for x and that we can do multi-step simplification. So this is the high water mark in difficult algebra simplification that we have to do in our college algebra course. But it's something to strive for, something to try. And if you can make this benchmark and do these kinds of problems consistently, then you're in a good position when you go to calculus.